ladies and gentlemen. A very good morning to all of you. It's indeed an honor for me to be invited as a guest speaker for this session. Today, I'm going to share with you all about the relevance of Scada in Industry 4.0 environment, a view from the sewerage industry in Malaysia. The presentation today will be focused on four major components, namely the sewerage management in Malaysia, Malaysia's sewerage industry outlook, intersection of elements of Industry 4 and the future of sustainable development. And the last part will be focused on the remote monitoring system, climate change adaptation. The main reason transpired for this topic is indeed closely related to the increasing frequency and magnitude of extreme events such as heat wave, unprecedented rainfalls, thunderstorms, and storm surge events around us recently. Global water use actually has increased by a factor of 6 over the past 100 years and to grow steadily at a rate of about 1% per year as a result of increasing population, economic development, and shifting consumption patterns. Combined with a more erratic and uncertain supply, climate change will aggravate the situation of currently water-stressed regions and generate water stress in regions where water resources are still abundant today. Physical water scarcity is often a seasonal phenomenon rather than a chronic one, and climate change is likely to cause shift in seasonal water availability throughout the year in several places. There's lots of discussion surrounding on how to build a sustainable future for our planet. Many actually finally have coming to terms with the reality of climate change. Most of us are seeking solutions for change and attempting to identify how we can actually manage our resources in the years to come. Adaptation and mitigation are two complementary strategies for managing and reducing the risk of climate change. Adaptation actually encompasses a combination of natural, engineered, and technological options, as well as social and institutional measures to moderate harm or exploit beneficial opportunities from climate change. From the sewerage industry purview, the rise of concepts like the industrial Internet of Things and more formalized digitalization movement like Industry 4.0 have led many in the industry to wonder about the future of automation, especially of automation hardware and software. Clearly, technologies like sensors and controllers and industrial networks won't disappear, as they provide the key source of data and data conveyance required by IIoT. But what about automation technologies like Scada? How will such technology adapt or be replaced as industry has become more connected? Can the two concepts be integrated? And what the role that they play in the wastewater industry of the future as a new tidal wave of data from the IIoT spaces? So now let's have a look on the sewerage management in Malaysia. Before we move further, I would like to bring you all a glance through the history of sewerage system development in Malaysia. During Malaysia's pre-independence period, the development of sanitation facilities was very limited as the need for sanitation was not critical. In the 1950s, towns started to develop and population densities began to grow. There was increased need for improvement in the sanitation sector. Technological advancement at that time was limited to the primary system providing basic primary treatment via sedimentation and digestion. After Malaysia's independence in 1957, the need for improved sanitation extended to community-based sanitation as more towns were established. From individual septic tanks in 1950s, we have moved to the communal septic tanks in the 1960s. In the late 70s, aerated lagoons were introduced to serve a larger population within a limited land area reserved for oxidation pond. Improvement in the sewerage system became more prevalent in 1980s when the environmental quality regulations of 1979 were enacted. From 1990s onwards, technological advancement, especially in computer technology and microelectronics, promoted the enhancement of sewage treatment system, including the introduction of full secondary treatment via mechanized sewage treatment plants, such as conventional activated sludge and extended aeration. From year 2010 onwards, the construction of regional sewage treatment plants with tertiary treatment and application of green technology have started to lead the trend. All newly built regional sewage treatment facilities are required to incorporate green technology in the design and process. For example, the reuse of treated effluent and electricity generation from biogas, which is obtained through the sludge treatment to minimize degradation to the environment, as well as to promote and improve environment for all forms of life. Looking at the sewerage profile throughout Malaysia, the coverage of sewerage services is overall on the rising trend, on par with the allocation provided by the Government of Malaysia. As of 2018, a total of 26.1 million population equivalent throughout the country gained the access to the public sewage services via the pipeline of about 20,225 kilometers. In terms of the capex allocation, a total of 3.6 billion USD actually has been spent for the upgrading of sewerage infrastructures in the country for the past 2 decades. Indeed, technology has been identified as essential enabling feature for sustainable development in the sewerage industry. Meanwhile, local application of technology offers possibilities for building infrastructure and creating opportunities. However, the effective and appropriate use of technologies requires considerations of the social, cultural, economic, political, and environmental ramifications. The opportunities and challenges of applying new technologies to all problems indeed require a clear guidance from both the professionals and policymakers who could leverage on the need to integrate technological expertise with overall development policy in order to achieve sustainable development. Hence, there is a clear need for the right business model to balance the financial, social, and environmental needs in order to achieve a suitable triple bottom line for a sustainable long-term model. The long-term infrastructure development plan needs to be developed in order to cater for priority needs to improve asset condition and meet the regulatory standards, as well as the long-term needs to enhance environmental efficiencies through the regionalization concepts. Now let's have a look on the Malaysia sewerage industry outlook, and based on the challenges that we are facing, the Ministry of Environment and Water is implementing various initiatives to restructure our sewerage sector in order to transform it into an efficient and sustainable industry with a higher level of governance. Besides, new policy has been embarked to rebrand the sewage treatment plant to wastewater reclamation as one of the alternative water resources. Further to that, wastewater industry has also been identified as one of the sources of generating renewable energy. In terms of the effluent that meant for recycle, the target has been set at least of 30% of the bioeffluent need to be recycled by the year 2030. In fact, technology innovations are reshaping the future sewage treatment system to be a closed-loop system. In order to adapt to climate change, the following are the features that to be incorporated in the design. For example, like energy neutral or positive, low carbon footprint, making a positive contribution to food production and agriculture, as well as harvesting the water for specific use. Now, let's move to the next chapter, which is the intersection of elements of Industry 4.0 and the future of sustainable development. In terms of global meaning, the Industry 4.0 concept is widely accepted as representing the digitalization of manufacturing. The 4.0 provides a historical context, positioning this new phase as the fourth transformation in production. The first industrial revolution was depicted by mechanization through water and steam power. The second saw the concept of mass production through electric power. Meanwhile, the third resulted in the rise of computer and automation. Now, we have the fourth breakup in manufacturing, the creation of truly smart factories with cyber physical system and communication across the Internet of Things. As of today, most of our regional treatment plants funded by the government has been equipped with the Scada system. Other than the standard features of the Scada, for example, like data acquisition, supervisory control, alarm management, remote video monitoring integration, Scada also gives us the insight into remote sites that may be difficult to access and allow us to analyze and store large amounts of data, to identify the trends and patterns, to monitor the remote sites for functionality, receive notifications when event occurs, anticipate maintenance and potential problems, and the last part will be the access to data simplifies our ability to identify where we overconsume. To facilitate the use of big data in the wastewater industry, computing solutions from other areas and industry are being leveraged. One such solution is integrated control system and data analytics. Ultimately, big data in the wastewater industry is about using the data we already generated to increase the performance and resiliency of our infrastructure. By analyzing the usage patterns, we can identify the causal factors surrounding spikes in consumption so that we can eventually narrow down the ways to reduce or use a cleaner alternative. To grasp a bright future, however, we need to realize that we have the power to change for the better. We should embrace the power of technology to amplify human capabilities. So as per what you have seen in these slides, this is basically a value map on how the integrated control system can give benefit for the sewerage industry. Big data and the powerful analytical capabilities inherent in Industry 4.0, together with a virtual prototyping, can also create an easy-to-use way for policymakers to prioritize the sustainable development goals according to the state their country is currently in, as well as better understand the situation they are facing. So now the question comes, are we ready for that? So now let's have a look on the current regional sewage treatment plant and what we are going to do when we are moved towards the remote monitoring system in order to adapt the climate change impact. Where stage 1 we will be using the web Scada, and the stage 2 will be focused on the dashboard. So basically, the Scada platform in the regional sewage treatment plants actually not only provide the capability to collect, sort, and analyze data quickly and display it on executive dashboard. A surge of new disruptive technologies emerging in the industry sector are actually changing the way the systems are designed and the way businesses operate. Some of the key disruptive technologies being incorporated into advanced SCADA system include the cloud, virtualization, mobility, big data and analytics, and Internet of Things. Moving towards the era of big data, remote monitoring platform has been identified as the core platform for the initiative. For the first stage exercise, a SCADA human-machine interface, or we normally name it as HMI client, will be installed at the headquarters and to be integrated with the SCADA system in each of the regional sewage treatment plant for performance monitoring. The authorized personnel will be granted access to the remote monitoring platform system located in respective regional sewage treatment plant via a secure IPsec VPN tunnel. In the stage 2 exercise, the remote monitoring platform to be installed in regional sewage treatment plant web server and enable authorized personnel to monitor critical status of the assets, events, stream critical CCTV footage, and visualize it in a single pane of glass. The RMP actually connects the disparate information to mitigate risk across environment by providing actionable intelligence and speedy incident resolution as well. The integration allows the organization actually to leverage the current investment to complete the missing link between operational domain and executive domain. And subsequent to that, we will be able to minimize the gap of design redundancy and improve the operational efficiency as well. Meanwhile, the data can be made access to the public for joint monitoring purpose. It is predicted by the year 2020, 50 billion devices or things will be connected to the internet. Therefore, the dynamics of an internet-based control system have become a living reality. With SCADA, cyber physical system, the Internet of Things, cloud computing, and cognitive computing, Industry 4.0 is an era that will change the dynamics of the entire industry. So by using the smart monitoring dashboard, we are actually can visualize the performance via the cloud server. So let's look about the demo. In the context of combating the climate change, science and technology and innovation actually has been proven to be the key drivers of economic and social development, transforming water resources governance and wastewater management at an unprecedented pace. The integration of science, technology, and innovations policies into water resources development strategies, as well as its combination with institutional and organizational changes can valuably contribute to raise the efficiency, improving the resilience, and fostering the transition to sustainability within and beyond the water sector as well. Such achievements offer new opportunities and responses to support sound decision-making in the governance and management of water resources while minimizing the impact of climate change. Innovation provides more affordable and efficient technological tools, enables their implementation, and is indeed central to translating water-related scientific knowledge and technological know-how into useful processes, services, and employment. Last but not least, it's hoped that this forum actually will serve as a platform for all of us to share knowledge across the industry. Meanwhile, a wider supply chain will be better positioned to achieve sustainable profitability and build the value of the business asset. Thank you very much.